A first live stream using the YouTube app, and it's mostly going to be staring down at my workbench, taking a look at this gearbox that I put together. But also I have got a Castle Copperhead as well to go with the 6-shooter motor, so I'm going to have to try and dig out my sensor cable as well, because I'll have sensorless start, which will be awesome. Anyway, let's take a look at this gearbox. So the gearbox itself reuses most of the Trx4 parts. So I've designed my own skid. Looks very similar to most flat skids. Printed it off in Petg, and then just shaved it down and sanded it so it's super smooth. I mean, anything that's on it just goes. Just noticed James has popped in the chat. James, your gearbox is printing right now. So it's essentially 4 pieces in the case. It recycles the TRX bearings, although Martin Moss of Mossy RC has been awesome and supplied me with some bearings to test for him, which are just TRX size bearing, but they've got this blue shielding, which seems a bit better. To put this gearbox together, it's actually a relatively simple affair. Most things should just push fit. So I'm just going to press these bearings into the pockets. I've printed it with enough tolerance that there's some friction, but if you want to push a bearing out, it'll push out. That stops the casing from cracking. We push the 3 in the back. Dead easy. Then there's 4 in this front one. Now, if I remember rightly, in the TRX casing, you'll have somewhere around 10 or 11 bearings. This only needs 9, and it's a kind of forward motor mount system. It'll become more apparent as we put it together. Feel free to ask any questions in the chat, and I'll try and answer all the questions that I can. So I've got my 4 bearings in there, my 3 bearings in here, and then this forward motor mount. Actually, I've redesigned to take 2 bearings. Now, these are a bit tighter because it's a bit thicker. The material seems to shrink slightly, so I might have to just nip these up in the vise, or you can just shave the lip out of the mount. Or if I put it on Shapeways, it'll be their SLS nylon printing, so that'll be much better. But I'm just using a little jeweler's vise from Amazon, and yeah, just took a few seconds. You could probably use pliers. So yeah, so that's my forward motor mount. Now, we're reusing most of the internals from the gearbox. I think there's 1 extra shaft that I've ditched, and a couple of gears. And so I've just changed some of the shafts that things sit on. So this shaft is the central shaft that runs down the middle of the gearbox. This is used for our idler gear. And all I'm doing is putting a shim on the end that's got the pin. And then they've got their own sort of neck on them anyway. So I just pop that in, and I can't be bothered to cut these down. You could just snip this down if you wanted to. I'm just really not bothering. It's not an issue. Then we take our forward output gear. So this has got the short shaft from the transfer box on it. That just drops onto the bottom. And these are spinning very freely at the moment. Then at the moment, I've got another short output shaft. The standard one's a bit longer, but this is out of a different gearbox. Just because I'm having some drive shaft issues, I bought metal drive shafts, but didn't pay attention to whether I got Defender or standard. And I bought the Defender length ones, which meant it was just a bit too tight. So I just swapped that out. Still working that up. We'll see how that goes. And that pops in there. So now what we're doing is we are changing the ratio of the gearbox. Normally, your spur gear would sit on a shaft, this is for the single speed box, that drives an 18 tooth, and that 18 tooth would normally drive this 32 tooth. In fact, it's a 16 tooth, 16 and 36. I've lost track of what they are, but it would essentially drive this big one, and then this big one would drive all of the small ones equally, and you wouldn't have any overdrive. What we're actually doing is we're having this smallest gear drive the medium-sized gear, which then drives the large and the same sized gear. And when I worked out all the ratios, it's been a while since I built this, so I can't remember the ratios offhand. When I worked them all out, that gave you 33% overdrive, but it did mean less gear reduction. So wherever my pinion is, oh, it's on my motor over there, I'm running a 9-tooth pinion and a 45-tooth spur and a 2700 kV motor, which very, very soon can be 4S, but at the moment I'm running it on 3S. So what I'm going to do is just pop the little pin in for this gear, and I'm just going to install this gear just so that I can check the tension on these gears and that everything is appropriately shimmed. The way this works is this case is a big triangle, so it should be quite obvious how it goes together. This shaft is a used shaft, so it's just got a few little nicks on it that make it a bit of a pain to install. The gearbox should just all clip together, and then it's a case of tightening it up using this wonderful Bosch electric screwdriver. Now previously I had the version that had the electronic torque control. This one has an actual mechanical clutch in it. So when you're dealing with 3D printed parts, you're less likely to strip anything because the clutch kicks in before you strip any threads. On some of the other ones, that wasn't the case. So there's 3 bolts. Talking about cases, there's 3 bolts on the rear of the case. And just need to push these bearings in properly. That is spinning really smoothly. And actually, because these gears are quite lightweight, yeah, spinning very, very, very freely, which is exactly what I wanted. So I'm actually going to crank up the torque a little bit so I can get this locked in. I want this case tight so that my gears don't slop around, and in fact I've got that cranked up slightly too tight. There we go. So our gearbox, that section is now done. Dead simple. What I'm going to do is actually mount it straight onto the skid and just check it for tension, because when you print things, there's a little bit of a tolerance to deal with, and that tolerance does cause some challenges in terms of when I put the motor plates together. And what that can do is it can make things a little bit twisted, and then you lose some of that smoothness in the gearbox. But that is spinning way nicer than a standard TRX gearbox. So that's the first section done. Right, the next section is to take this piece out that holds our spur gear and just temporarily install the spur gear so that we can get our motor mesh. And I can't see any chat on here, so I'm just going to check quickly. Sorry if this makes your eyes wobble. Oh yeah, orientation is locked. Rotate the device back. Okay, interesting. I don't know if I can see the chat or if anyone's chatting, so if you are watching, if you can just say hello, then I'll know if I can see the chat. It's the first time I've streamed from my phone. And in fact, I'm going to try and see if I can log in on... yeah, no one's chatting, so that's great. Awesome. Yeah, no one's chatting, so that's great. Awesome. Yeah. And of course, that's talking to me. Right, so now we've got this spur gear. This is so that we can set our motor mesh. And I've tidied up in here, so all my tools are where they should be rather than just all over. Right, awesome. So we've got our spur gear. That sits on the forward motor mount. Now I've not shimmed it, so it's not spinning as smooth as it can, although actually, if I move it forwards, yeah, that's super smooth. Double bearing in there, so super, super, super smooth. In fact, don't know if that comes up on camera, but yeah, no friction there at all. Right, now we need our motor. Now, unfortunately, the motor is still in the chassis. So, and it's also on the old ESC. Now this chassis is a standard Northwest Scalar Designs chassis. And what I'm going to do is pop the motor into the motor plate to temporarily fit it, and then install the motor plate. Actually, I don't need, I've lost track of the order of everything. Yeah, that should be fine. So just going to pop the motor on. Now the whole point of this gearbox was there aren't many options for the TRX. There are some options if you buy a G or the other types of gearboxes, and I've just realised that if I put this on I won't be able to attach it, so bear with me. I do actually need to put this mount on. This is the first time I've put it together in this configuration. Previously it didn't have the printed spacers and brackets, so I've tried to reduce this so it's got the minimum of screws needed, so that I can chuck it on shapeways. People can just get a load of M4 bolts and screws, whatever you call them in your country, and put it together. Right, that's all together. And this is the fun bit of these kind of systems, is trying to get a motor mesh. So I'm going to try and find some paper, which I've got somewhere. And what we're going to do is pop a bit of paper between the spur and the pinion, and that should let us know what's going on. Now, I was rambling about why I designed it. Just because I could, really. It's not designed to be a product. It's not supposed to be a revolutionary new thing. It's just, I wanted an overdrive gearbox. I didn't want to spend however much the RC Garage Hacks ones are, as good as they are. I love the 2 lows and the, can't remember what their forward one is. This is just a case of, you know, what could I recycle out of stuff that I already had. I had a load of 3D printer filaments. I also seem to be incapable of putting a pinion on a motor. I had a load of filament, so I just went for it. Yeah, designed it up in CAD, did the calculations for the gears, and just, why not, really? I don't have any training. It was just, that's like everything with your hobbies. If you enjoy something, you seem to be better at it than if it's your job and you're bored. So all I'm doing is just getting this pinion to stay still while I do the mesh. And then, yeah, it's a case of getting the motor bolted on, which I'm obviously making a hash of, but you know, it's not rocket science. I've left myself some nice access holes, where in fact the bottom bolt is completely open and the top one is accessed through the motor mount to make it really easy to get these two to mesh up. And then I'm just going to back off those bolts. It's a bit tight because these holes, I don't want it to slip. Back off those bolts and then just work on this mesh, which actually doesn't look too bad. Get that paper in there. And then you just squeeze it together and then you pull the paper out and then you should have a lovely mesh. And then I will rescue the ESC and everything else out of there, because actually what I'm going to do yeah, that feels a little bit loose. I'm just going to yeah, that's great. That's absolutely great. And to unplug this motor, because I have to be soldering up a new ESC anyway, so it really doesn't matter. Right, now I've realised I've actually mounted the motor upside down. So I'm going to have to take that out and start again. Because really I want my motor wires to be above where the rocks are going to be poking in and cracking stuff around. So yeah. But yeah, a motor mesh, you've got to remember that your spur is always a bit egg-shaped if you're using a plastic spur, and always gonna have some kind of imperfection. So you don't want the mesh so tight as to cause any challenges, but at the same time you don't want your motor flopping about on the trail. Right, so I'm just going to move that pinion a bit further out so it's got more bite on the motor, on the spur. Great. So again, I'm going to do the paper trick. Pop that paper in, squash it as tight as it'll go against the paper. Now you're supposed to actually find the tightest spot on your pinion, but I'm not that fussy. As long as it's tight enough that you get a decent mesh and that it's not so tight that it bites, which actually it just is. There must be something about the tightening down of that just caused a problem. Okay, that feels good. That feels really good. Okay, what I'm going to do is just tighten up that motor. And this is the 6-shooter, the Holmes Hobbies 6-shooter, which is a Puller Pro with 6 poles instead of 4, which means it's probably lacking a little bit of the power of the standard puller. But that's good. Right, we're going to just get that spur off so that we can install the shims to make sure that the spur actually plays nice and easy. Right, so gearbox, dead easy in terms of putting together. So far we've done about 6 bolts. We are 20 minutes in, and I would love to say it's dead easy because I know, because I designed it, but actually I've forgotten how this goes together. And this style is the first time I've put it together with the printed spacers. So previously the gaps in here were using little nylon spacers and long bolts to get the right spacing, because you can draw it all up in CAD, but then printing tolerances, measuring tolerances and everything else, they can be a bit of a pain. So here we go. I've got one more. Yeah, this really is the best thing I ever bought for screwing together 3D printed parts. So there we have it. We have all of our gears in here. We've got our motor at the front. I can put it down and it kind of balances, but I mean, it's all the weight at the front. Now what we do is we're going to install the spur. So we put the gear on, you know, completely different rotation. That pushes in the back and just goes all the way through. And then what I try and do is pop some shims on here, just to keep the spur away from the plastic parts. I mean, in reality, it will just rub the plastic parts out the way, but this, if I can push it through without causing myself too many headaches, this might take a few attempts because it's the first time I've done it with this system. But it should just push through. And sometimes when you're using old parts, it's a bit of a pain. So you get the old pliers out and just push that bar forwards. And something is just catching. I think there's a few little nicks on the rod that goes through, because the gear's in, the bearings are in, the spur is off. So I just need to tap it through, which I'm not afraid to do normally, but on a live stream, obviously, it's a little bit more worrying. Okay. There we go. Right, that's nearly there. Great. I just need to get the shims and get everything to sort of align properly. Yeah, I've got my pinion in slightly the wrong place, so it's just stopping it from settling. Right, that's great. That's going to need all the shims, so it's got to go back out, and it slides off there, so we'll push that back. So in this case, it needs 5 or 6 little shims. The shims I'm using are 0.1 mil shims. And the purpose of these is just to stop that shaft from sliding out the back. It can drift around a little bit, but if it drifts too much, you lose the little pin. You spend an hour or so looking for it on the trail, then you go home in a big sulk because you've lost it. This gearbox as well, I don't know if I'm going to use it for trailing, but I am, to test the durability of it and the strength of it, I am going to install a 3300 kV axe on it, just to give it the chance to really get thrashed. Just going to push this in. Again, same process, just knocking past little nicks and bits and bobs that are stopping it from going all the way through. And put our spring washers on the other end, and then do up our spur. Now this thing's got smart sense on it, so I should really be running a slipper eliminator kit, but I'm not, and my wife has told me I'm not allowed to buy anything else for RC, so that's out of the question. Right, and I have noticed I have managed with the bashing to just split a layer line in the mount, but not to worry. I have some nice industrial strength super glue somewhere. Hopefully that's the open one. No, I was going to put a dab of that in and that'll hold those layers together. It's not a crack all the way through, but that'll just stop it from getting worse. And that's from me smacking on it with a pair of pliers. I mean, it's not the end of the world. So yeah, don't use this as an instructional video of how to install it, because smacking it with a pair of pliers seems to be quite bad for it. Right, that is nice and tight. So I'm just gonna make sure that slipper is tight, and yeah. So that is a 6-shooter with an overdrive gearbox. So now the Copperhead. I may as well get this installed, because then we can test the 6-shooter. And I'm going to need, because I'm live streaming on the phone that I would use to program, a spare phone that is out of power. Here we go. So we'll charge that up and then we can program that in a minute. Ah, fantastic. Our Copperhead has come without a... oh, that's interesting. Oh, it comes with an auxiliary wire as well. Oh, that's cool. I didn't know it came with an auxiliary wire. Now, most people would use that for drag brake, but I like to have 100% drag brake. So I'll have to have a think about what I'm going to use that for. Maybe motor timing, for if I want to go a little bit quicker. Because I don't like the motor timing on all the time, but we'll see. Okay, well, that poo-poos that idea, because it's come without a connector on it. So I'll just use the ESC that's on this one, and then we'll start doing a rail swap. And while I remember, let's take a break and get my sensor wire out. Oh, lost the stream there. This will be a sensorless startup. On the new gearbox with everything else. So here we go. There you go, nice and smooth. That is nice and smooth. So that gearbox I'm happy with. That battery I'm not happy with. And so it's going to pop that battery into charge. Actually, it's storage voltage, so we'll leave that on. Otherwise, I'll totally forget to discharge it, and who knows what's going on. Right. So that's the skid, that's the motor, that's all sorted. Let's get this transferred onto a set of Team Edition rails. can tell by weight because the Team Edition ones are aluminium. Now, I've been very fortunate that I got selected as a team builder. There aren't many competitions going on in the UK, so being a team driver is kind of out of the question. But yeah, for the Northwest Scalar designs, I'm classed as a team builder, which is really cool. Which means I get access to these. These are awesome. These are the Northwest Scalar Designs Team Edition rails with a crazy rake on the skid. And also loads of different shock and link locations, but also super high rails for the panhard. Not for the panhard, well, yeah, for the axles basically. So really good for portals. So I'm going to take this and bang it on some Team Edition rails. So I keep all my on my super low stubby sliders, which are available on Thingiverse and Shapeways. Knock yourselves out. But everything's on Velcro, so I can swap things over a lot. Mostly because I tend to smash my trucks about and break them a bit too often. So just need that extra help. We'll do some soldering on the ESC in a minute. I'm just going to get the majority of this apart so I can put the new rails on and just see. I want to see what kind of pain I'm going to be under when I get to the links, because I got some centre of gravity remote control titanium links, which I've put on. The big downside to them is, oh, cheers, man. Someone just said they can't wait for the trans to be available. I am going to put the Thingiverse files up very, very soon. But yeah, I've got the centre of gravity remote control links. I've got them in standard TRX and then just extended a couple and shortened a couple to make them work with my individual setup. But the Team Edition rails have got super long rear end, so they actually, I'm actually probably going to use my old GPM aluminium links for the uppers, just to make it all fit. If anyone's interested, I'll probably put these spacers up as well. These are Petg Spacers, 70mm on the front and 65 on the rear. And the skid is 80mm. And that's the spacers mostly removed, I think. I almost always mount my shocks into a spacer so that any pressure on the chassis goes into the spacer coming from the shock. Just seems to work for me. Been lucky that way. Now these rails are the steel rails, and it was running the aluminium rails, but I crashed this thing off a very, very high thing that I can't normally get up. So I was a bit disappointed that I broke 2 sets of aluminium rails doing stupid things, and then I broke a set of steel rails by driving a truck off a 40+ foot cliff by being silly. So yeah, I can highly recommend Northwest Scalar Designs rails because I put them through absolute hell, and I've had to do some pretty crazy things to break them. Aluminium rails, 20-foot drop to flat to bend them and break them. The steel ones, yeah, 40-foot to flat, and they twisted up quite badly. But yeah, the amount of abuse I've put on these rails is incredible. I'm still very, very thankful that I went with the scattergun. That noise you can hear is the clutch just kicking in, so I'm just going to crank it up a bit. Get these sliders off. They're just playing hard to get. Now these sliders are super low CG. There's the bolt goes inside, so it does get you stupid low. But the downside is you catch up on things. But that's why I print them out to PETG and then sand it down. So this is super smooth. Have I checked out the Flat Gecko chassis? I have seen the Flat Gecko chassis. They are very interesting, those Flat Gecko chassis. I'm not sure if I'm quite ready for carbon fibre. I'm a bit of a brute. What kV motor? The 6-shooter only comes as a 2700. So it's 2700 kV. I run fast motors and lots of gear reduction. And the reason for that is the higher the kV you run, the more power you have. And it's power that gets you up a hill, not torque. Torque gets turned into power. And so having a higher kV gives you a flatter power curve, so you've got more usable power. Low kV motors have a really tiny spike and then they tail off really quickly through heat. So that's why I tend to run high kV motors. Actually, I'll be able to run 4S soon enough. So yeah, so that's the standard scattergun rail. This is the Team Edition rail. And if we hold them together at the shock mounts to give you an idea of how they together, and has a much lower skid, but also loads more space for the axles. So I've been able to slam the scattergun down to about 58mm off the table. I think this Team Edition is going to be stupidly low, which means I might even take the limiters out of my front shocks because I won't need them. Because I'll need that extra breakover clearance to be able to get over anything. I am just undoing stuff and throwing bolts to one side because I'm just assuming it's going to be a journey of discovery. I did ask the team members if anyone's actually built this chassis yet, and as far as I'm aware, no one has. So not only is it a secret chassis that no one knows about, I think I'm the first person to build one, and more than likely the first person to put it on the internet. I've just dropped the bolt that I need. Oh, never mind. I'll find another one. In fact, yeah, got another one just there. And I'll need a spacer. Smaller spacer. I'll work that out in a minute. Right, just got to get this last one off and then we are apart. Cool. Right, that's it. So that's my scattergun rails off. Very heavy. So yeah, these weigh about 300 grams. I have not yet weighed Team Edition rails, so let's let's have a test. Now I'm running a 4-link, so this is without panhard. Oh, they're not easy to weigh because of the weird shape. 105 grams compared to, yeah, 280 grams. So quite significantly lighter. Right, so that's our old skid. Now these skids are Petg. I do want to print Delrin at some point, but I haven't got there yet. So it's still Petg. It's printed at 240 degrees, 100% infill, shade, sanded and so smooth. If I run it against the upper side that's got the texture, you can hear the noise. Run it against the bottom, super smooth. So smooth that if you go at it with a knife, it scratches, but it's not like, it's not rough because it's just skimming off. Right, so push the axles to one side. We'll sort the spacers out in a bit. Off we go. Try not to get too much super glue on my hand. Yeah. So, what do I need to do first? I need to think at this point. I need to get my lowers into the skid. And I've not done any tolerancing of this skid, so I'm just pushing stuff together. Yeah, okay, that's not too bad. So, where did I put? Okay, my internet, as usual, is a little bit flaky. So, let's see where we can get to. Right, there we go. So I'm just going to, yeah, get the rear links on. The front, the two are held on biders, so I'll have to sort that out in a minute. But I just want to see where things are going to sit, that kind of stuff. Come on. Great. So my axles actually well, that's crazy. My axle's going to be sat way, way, way too far back. So I'm not panic about that right now. I will think about that later. Let's do these fronts and see how far off we are with the fronts. Okay. Okay, great. Right, let's get that in there. Now, I'm sure people will be saying this is the worst way to put stuff together, but you know, it's just the way I build. Oh, close enough. Right, I've got that on there. So the front is looking good. Now I think, yeah, that's a good length. I was worried that the motor was just going to hit. So now I've got those links off, done, I need to have a think about the rear. What I could do is probably print out a new skid and do it that way. But that feels like cheating because that would be too easy. So what I'm going to do is just check. Right, okay. Yep, well, that's going to pose an interesting challenge. It's going to compare this to a standard. Yeah, okay. We'll get there. I'm probably going to focus on just getting the front all together, so won't be too long. I apologise if the stream stops and starts. That's just my Wi-Fi cutting out. I'm in the garage, so it does have to go through a brick wall. Okay, great. I have got the skid on, the sliders on. I've not done the rear yet because it's just totally in the wrong place for me. What I'm going to do now is look at my upper links and just make sure I can get those mounted. And I'll probably get a drive shaft in because that'll make the biggest difference. So I need one of those. So let's get this drive shaft in. I saw a chat, someone's just brazing scaled theirs. I really wanted a brazing, but they wouldn't ship to the UK at the time that I wanted it. And so well, yeah, as is hopefully quite apparent, I went with the scattergun. There we go. So I just need to get this drive shaft pin in. I think I can just reach in. We'll do it from the top. There we go. Cool. Right. That's the drive shaft sorted. And on hopefully I've got the same these 4 links. That looks about right, but we'll have to see. Let's try. Yeah, cool. Okay. So the 4-link versus 3-link, I guess, if anyone's interested. It's just where you put your servo. They both, if they're both set up correctly, both have the same steering performance. In terms of weight balance, obviously having the weight of the servo on the axle is going to make you better. Brazing is great. Shape weight. Ah, someone's talking about brazing. Yeah, I used the brazing skid on this. I thought it was an excellent skid. But yeah, I mean, shapeways is expensive, but it's not. When you put your own stuff on shapeways, you'll soon see that the majority of the money is going to shapeways, not to the seller. That's because they use extremely expensive industrial grade printers, and you just will not get the same print quality at home no matter what people tell you. Because they're using sintered nylon, so they have big sheets of like nylon dust essentially, and the printer lasers your design over the top of that layer by layer, which is why when you get your parts and they're coloured parts, they will eventually turn white because they dye the nylon afterwards, which again just adds to the strength because it means that the nylon hasn't been interacted with a dye or anything else in the middle. Right, that's my 4-link on. Now it's a case of working out pinion angle, and it looks like there's going to be a few interesting challenges. So immediately I can see that my 4-link is too long on the top, so we're going to be sorting that out. Drive shaft. So I'm finding a couple of things. One is that the gearbox, this link is just catching on this arm of the gearbox. So I might have to make that wider or print a slightly different skid. I could clearance it out a bit, but I want to... What do I want to do? I think I need to adjust my 4-link, to be honest, because it just doesn't seem in the same position. Let's have a look. Yeah, so the hole is further forwards on these rails. That's interesting. So we'll use a different hole. Nice and simple. Just grab our washers that fall out. So I'm moving this from this hole to, I don't know, any one of a number of front ones. So this is where we start to hit all the snags and the issues. That's just not going to work. So those holes are pulling my servo into my motor, so they're not the right holes. We can try these ones, which might be the right ones. Just got to keep attaching links to things until we find the right place, I guess. But yeah, I'm disappointed that I've managed to basically get my skid a bit wrong. Oh, that's going to be close on that link. Okay, let's hope that we get some tolerance somewhere. Okay, it's all a bit tight in here. In fact, I'm going to put it on here and hope that gravity helps me a little bit. Or not, or just pull the whole thing off. Cheers, gravity. Right. So these rails seem really cool. It's just they are absolutely not a direct bolt over from a standard scattergun. So I'm feeling like I'm back to square one. Okay, how does that put me? Okay, that's good. But now my high clearance links and drive shaft are interfering, but let's just keep going. So I need something bolted together before I can really work out the different links and everything. Okay. Of course, the challenge with these links is the closer they are together, the more likely they are to rub on each other and catch as the suspension goes through its cycle. See if I can just get that finger tight to just hold. Great. Okay, so we've got an ESC and everything else dangling off, but that's fine for now. So we've got some challenges with this frame, so I'll just talk through them. One, the rear hoops seem in a bit of an odd place. I'm just going to grab a ruler to see. Yeah, I need to look at wheelbases and things, but yeah, that would be not massively off a standard wheelbase, and in fact it can't be off a standard wheelbase because that's how I build them. The skid hasn't changed in design, so I need to work out what I'm going to do over here, because this arc is not where my axle is. So that's interesting, and this arc is yeah, is what's happening is because I changed the design of the gearbox, I missed the fact that this bridge used to be a high clearance piece, and I think what I'm going to do is I'm going to take off these lengthened pieces and just have the gearbox here and do this bridge with 4 holes, so it's wider and across those 4 holes, because as it stands this link is catching on the gearbox and the other one is just clearing. So it's not the end of the world, but a little bit disappointing. And then the motor isn't found on anything, it's just the links won't articulate. But yeah, this wheelbase is weird, so I need to work that out too. I think, yeah, because everything's in the right place. I'm just not sure what this rear is supposed to be doing. I think it's too short for me, unless I'm just running a weird wheelbase. Yeah, I need to look into that. Yeah, it's been pretty interesting. If I look at these links, yeah, these links are going to have to come out. We're going to have to use these GPM ones, which would run from there to there. And these are adjustable in length, which is really cool. So they would, yeah, they would just about fit, so they'll be fine. Yeah, looks like I need to go back to the drawing board. Quite literally. The gearbox is smooth as hell though, so that is really cool. But yeah, I need to print a new front plate, a new motor plate, and possibly a skid. Although I might be able to drill this one as a prototype. But yeah, I think I'm going to call it from there because it's going to be interesting. Turn the high clearance ring. Yeah. So the bend's on the skid. Well, if the bend was on the skid, it would be hitting. Someone mentioned turn them around so the bend's on the skid. Would that work? It might do. The challenge is this just doesn't have enough clearance, and on the previous version, which I've actually chucked in the bin, on the previous version the bridge straddled, so there was space on both sides, and on this version the bridge is kind of not quite straddling and sticking out, and I should have picked up on that. So I'm going to make this bridge work properly, and then yeah, we will see how it all comes together next time. I think I might solder up the ESC just so that that's done. Yeah, why not? Let's do some soldering and then I'll finish. So should be relatively easy to do. As you can see, my cable management is nothing more than just zip ties. Right, we will desolder this and move to the next one. And we'll unplug everything from my receiver. That's the Castle BL link. And go. Don't know why I've just unplugged everything from the receiver, because it doesn't need to. Okay, cool. Let's get this Copperhead soldered up and chuck a battery on it and see how smooth it is. if I can get my steering back in place. These spectrums are an absolute pig sometimes. There we go. Cool. Right. Easy as that. So I'm sure people have seen me solder before, but we'll do how to do soldering super quick, super easy. Run through. So first thing first, soldering iron. And yes, that affects the YouTube lights, but hopefully the camera picks it up. Right. Turn the soldering iron on. This is a, what is it, TS100 soldering iron. I absolutely love it. I think it works brilliantly. Because I want to do this as a rush, I'm just going to crank it up to 370. All I'm really going to do is desolder and just solder back onto the copperhead wherever I've left it. Oh, that's for the fan. So it doesn't have an auxiliary wire, it just has a fan. That's going to come off. Right, that soldering iron's heating up, so we'll get this fan off. As you can see on my old ESC, I actually completely decased it. Not necessarily on purpose, just I super glued it to something and it decided not to stay on. Right, that fan, that's gone, excuse me. Oh, you know what? That can stay off too for now. Or does it just clip on? Oh, that's a nice touch by Castle. If you take the fan off, you can just clip the plate now back on. That's the sensor port. It's great. So flux. Oh, excuse me. Flux is always your friend at this point because it just makes things much easier. Every time I finish soldering with my soldering iron, I always cover it in some solder. So I'm going to use some flux. Retin the soldering iron, clean it off, and then get started desoldering these. Desoldering is pretty easy. You can use a desoldering pump, you can use a desoldering wire, or in the case of battery connectors, you can just apply a load of heat and pull it apart. I also managed to forget to put heat shrink on this, so I'm just chopping off the electrical tape with a knife sharp enough to go down to the bone if I slip. So that'll provide some interesting YouTube ratings. I did say this wasn't for kids and it's for adults, so it'll be fine if I bleed everywhere. Oh, it's really not coming off. Okay. Well, that was useful, wasn't it? You know, it decides to disconnect. So a bit of solder on the soldering iron, push it against the flux that's on the plug. Just sit and wait until everything bubbles and gets nice and hot, and then just sort of wiggle away until it pops off. Simple as that, really. And then I want my Holmes Hobbies nice thick JST wires. So I'm just going to get those. They are absolutely caked in solder from when I did a bad job of this last time. Right, they are disconnected. Great. don't be scared of soldering, just use loads of flux, well, yeah, cheap, basically. So on that wire, that's my old ESC, so that is a Castle Sidewinder. You can rip off most of the case and save yourself 10-15 grams. I'll probably do the same to this Copperhead at some point, just, you know, right now probably not a good idea. Okay, so the bad news is my internet keeps dropping in and out. The good news is we might be moving soon, so I will have better internet for when I'm doing this stuff, which will be nice. Right, just trying to get the solder off these so I can squeeze these cables in. And the cables are just going through this little grey thing that helps keep the plug closed. And we're going to push that all the way down so that these are nice and long. And we're going to try and squeeze both of these through the heat shrink. And in fact, this one still has too much solder on it. Let's just flatten that down. Let's flatten that down. Dip in the flux, clean you off, tin you, off you go. Right, always try and keep a bit of solder on your soldering iron, just so it's not exposed to the elements with the heat. Just keeps the tip lasting a bit longer. Or you can just buy new tips. Do you know what? They are not big enough, so I will get the slightly bigger ones out. There we go. 4.8s, that's what we need. You can work out the right heat shrink from the appropriate gauge of wire if you go on the internet and find it out. But yeah, so is that a TGH or Salinas transmission? No, it's a I designed that transmission, which is why it doesn't fit properly, and I need to make a few minor tweaks. But yes, I designed it, not to make any money, just well, just because I could. Just need to find the positive and negative on this. I always forget. They've been melted off from successive soldering. In fact, if I get a battery, just double check. Right, top one's negative, great. So I'm going to fill the terminal with some solder, try and get it all in there. And then we're just going to try and squeeze these two wires together. And the heat's transferring really quickly because my iron's got plenty of heat on it. And then by burning my fingers, I'm going to hold this wire after heating up the plug. You don't need a lot of pressure, you just need to be able to touch it to apply the heat. I've heated up the plug to melt the solder, and I've stuck the wire on. And got that too hot. Right, just need to hold that plug. Oh. Hot. And that's about it really. You just you get the blob of solder, you push a wire on it, squeeze it all together, and then hope it all connects together. And then do the same on the bottom one. Just going to clean this up, tin it, try and get the wires to connect. Which just gets a bit of heat into the wires. And then it's the same process, just on a separate connector. Oh, it's getting a bit hot. Right. There we go. Right, awesome. So they're sorted. We're just going to let that connector cool because that'll be holding a lot of heat. We're going to cover our tip in a lot of people have tried to get the TGH transmission. I think personally I would go with the Salinas. I know the TGH one is good and everything else, but I really like the Salinas one. I like the gears that they use. They use some really beefy gears, and they don't make silly mistakes like me in their clearancing. But hey ho, right, that's cool. Right, so I just slide my heat shrink down, and then hopefully, if I've remembered to put it away, get my heat gun out. And what I probably want to do is just double check if I put a battery next to it, not connected, have I done the right terminals to the right terminals? And I have. Woohoo! Great. Right, get the studio lighting back. So just lay it down. So now we have a Copperhead, and we're going to pop it onto our 6-shooter. So someone's just popped up and said, am I going to use a revolver? No, I've just sold my revolver to a friend of mine because I have the 6-shooter, which is a censored motor, which is why I've swapped ESCs. I would say if you've got a revolver, you absolutely want a Copperhead or the cheaper Sidewinder 4 for the cryo drive, because it gives you much better startup performance. So I've done a crappy job. That's not going to fit all the way down, so I'm just going to leave it like that because it'll hold it together. Let's bring this transmission back in. Try not to put anything on top of my hot soldering iron. And I did get my sensor cable out, which I've immediately lost. So there we go. Holmes Hobbies sensor cable. We will plug that in. Hopefully these only go in one way. If they go in 2 ways, then this could be a fun video. I've never actually run censored brushless, so this is completely new to me. Oh, actually, yeah, I mean the axe is a censored brushless, but that's like an all-in-one system and has a proprietary connector. Great, right. Let's see how the Copperhead drives our transmission. A is A, isn't it? Yeah. So that JST was for a direct drive servo. And that sensor wire goes on like that. Turn on my transmitter. Find my receiver. No, that is solder. Looks like a receiver wire. God, I am so disorganized. Where is it? There we go. It's just hanging off everything else. Yeah. Let's go for it. We can program this as well because my programming phone is alive. So we go like that, and then we battery it up. And it turns straight on because it's got a physical switch. That's amazing. Right, so let's try the low speed startup. Oh, that is interesting. Oh my God, that is smooth. However, I have completely stuffed up and not done a motor pairing. So Castle motor pairing, hold your trigger down with your ESC turned off, turn it on, and it should beep at you, and then start beeping. And then I can let go. So what I did there was hold the throttle to full, turn the ESC on. When it started beeping at me, let go of full throttle, go to full reverse. Then when it does its little dance, let go. That finds its neutral. I don't know what it's beeping at me for now. Oh, that starts up so beautifully well. So it's always started up with a little bit of a judder with the Sidewinder 4. That's crazy. Now, everything is set up completely wrong, so that's fine. Now, I don't actually run a lot of throttle curve. In fact, I don't think I run any throttle curve. It's beeping at me because that is Castle's default wow. It comes up as a Mamba XL. The first time. Okay, and the passcode. Okay, interesting. So it comes up as a Mamba XL2, which was quite interesting. That's what my B-Link has picked it up as. But the good thing is the B-Link has retained my pin, which was good. Okay. That's going to suck if B-Link doesn't work with the Copperhead. Because that beeping is annoying and I want to set a few parameters. So let's see. And the main thing that I want to set is reversing the motor direction. But yeah, that starts up. That senseless start is awesome. Right, so let's try connecting. It says power off the ESC, then power on the ESC. I think I'm going to be having some interesting challenges with this because I don't actually have a Windows computer in order to be able to do anything. Now, I wonder if my Castle link is out of date, in which case I'm just going to update it, because it should be Castle link compatible. But if it's not, that's really going to suck. So I'm trying to get updates over the internet, but obviously I'm streaming as well, so that's a pain. There's no update for the Castle app. Interesting. Let's try Castle Link again. Okay. Link controller. Keeps telling me to power off the ESC, then power on the ESC. So I really am disappointed with Castle, because I would have expected this to just work. That's interesting. It says it's compatible with Castle Link. Oh, well, I mean, it's fantastic in terms of how smooth it is, but it's going to be going backwards, and so I will try and sort that out another time. I think I'm going to go and get a cup of tea and redesign my casing to have a different bridge, because the bridge will cause problems. I tried something different. It didn't quite work this time, and we'll just fix it. But that's it. Thank you very much for watching. Very different live stream sort of format this time. I've done a bit of everything. This thing's going to keep beeping at me, so let's get that unplugged. I hope you have a fantastic weekend, and if I do stream tomorrow, that will be a surprise to me because I've got quite a few things on, but hopefully there'll be more of this. And yeah, people saying reverse the channel 2. Yes, I would love to, but if I reverse channel 2, I can't program in, well, I mean, I can't connect, so I can't program in the throttle curve. But if you reverse your channel, the motor runs in reverse, and so it applies the reverse curve, and then it doesn't have as much power out the box and all the other things that you have challenges with. But really good suggestion, thank you. Yeah, let's leave it at that. I'm really glad. It's the gearbox is coming along nicely. This is the first time it's in this format, this case. The case is there to protect it from rocks. It's not there to protect it from water. It is not a sealed case. But otherwise, yeah, stay safe, stay happy, and I'll catch you all next time. Thank you, everyone.